Hello basic calculus students. In this video I will discuss module 1 lesson 6 of the basic calculus for senior high school. Our topic is continuity of a function. Learning competencies. Upon completion of this lesson, you should be able to number 1, illustrate continuity of a function at a number. Number 2, determine whether a function is continuous at a number or not. Number 3, illustrate continuity of a function on an interval. Pretest. Determine if the polynomial or rational function is continuous at the given value of c. If the function is continuous, find the limit as x approaches c. Try to answer this pretest honestly and intelligently as possible. Here is the continuation. This is a 10-item pretest. Here is the last item. Now, as we have observed in our discussion of limits in lesson 1 and lesson 2, there are functions whose limits are not equal to the function value at c, meaning limit of f of x as x approaches c is not equal to the value of the function when x is c. Limit of f of x as x approaches c is not necessarily the same as f of c. This leads us to the study of continuity of functions. In this section, we will be focusing on the continuity of a function at a specific point. Limits and continuity at a point. What does continuity at a point mean? Intuitively, this means that in drawing the graph of a function, the point in question will be traversed. We start by graphically illustrating what it means to be continuity at a point. Example number 1. Consider the graph below. Is the function continuous at x equals 1? Solution. To check if the function is continuous at x is 1, use the given graph. Note that one is able to trace the graph from the left side of the number 1, number x equals 1, going to the right side of x equals 1 without lifting one's pen. This is the case here. Hence, we can say that the function is continuous at x equals 1. So let me elaborate our solution. If you look at the graph, we have a straight line here. Now, we pay attention to x equals 1. So if x equals 1, the value of y or the value of the function is 2. So in our solution, if we are able to trace the graph from the left side of 1, ito yung 1, this is the left side. So start from this part of the graph. If we are able to trace the graph, okay, going through the right side of 1, where is the right side of 1? Here. Okay, if we are able to trace the graph of the function without lifting our pen. So, ibig sabihin, tuloy-tuloy tayo nang hindi natin inaangat yung pen. Pag ganyan yung case, sinasabi natin na yung graph of the function is continuous at the given point. Example 2. Consider the graph of the function g of x below. Okay, so here is the graph of the function. G of x is defined by 3x squared minus 4x plus 1 all over x minus 1. Is the function continuous at x is 1? So here is x is 1. Solution. We followed the process in the previous example. Tracing the graph from the left of x is 1, going to the right of x is 1. One finds that she or he must lift the pen briefly upon reaching x equals 1, creating a hole in the graph. Thus, the function is discontinuous at x equals 1. So, balikan natin yung graph. Ito yung x is 1. Ito yung left side niya. So, the part of graph at the left of x is 1 is this. Okay. Now, at the right of x is 1, okay, this part, the part of graph at the right of x1 is this. So, if we trace the graph from the left of x is 1, pagdating dito sa x is 1, sorry, balik natin. Pagdating dito sa x is 1, nakikita natin merong hole or butas dyan. Ibig sabihin, at this point, hindi define yung function. So, kailangan natin iangat yung pen, okay, bago tayo makatuloy sa right side. Pag ganito yung case, sinasabi natin na yung graph of the function is discontinuous at the given point. Sa madaling sabi, pag tinignan natin ang graph, pag merong butas, pwede natin sabihin na yung graph ng function ay discontinuous doon sa coordinate ng x or sa value ng x na butas yung graph. Kung wala namang butas yung graph, ibig sabihin, pwede natin i-trace ng tuloy-tuloy, hindi natin inaangat yung pen. So, continuous yung function. Example 3. Consider the graph of the function h of x is 1 over x. Is the function continuous at x is 0? Solution. If we trace the graph from the left of x is 0, we have to lift our pen. Since at the left of x equals 0, the function values will go downward indefinitely. While at the right of x is 0, the function values will go upward indefinitely. In other words, limit of f of x as x approaches 0 from the left. So, pag may nakita kayong ganitong symbol, 0, mayroong negative dyan. Ang sinasabi sa atin ng symbol na to ay tinitrace natin yung graph galing sa kaliwa, from the left ng x. Okay? Kaliwa ng x. Limit of h of x as x approaches 0 from the right is positive infinity. Thus, the function is discontinuous at x equals 0. Okay, balikan natin yung graph. Pagaling, ito yung x is 0, which is the origin of the Cartesian plane. If we look at the graph, from the left of x is 0, pababa siya ng pababa. So, yung sinasabi ng araw na to sa atin ay tuloy-tuloy lang siya pababa. From the right of zero, kung titingnan natin, yung graph naman ay pataas ng pataas. So, kung i-trace natin to, pagdating dito, kailangan natin iangat yung pen para makalipat tayo doon sa part na yon. So, makikita natin, the function is discontinuous at x is 1. Example number 4. Consider again the graph of the function h of x is 1 over x. Is the function continuous at x equals 2? So, balikan natin yung graph. Ito yung graph ng 1 over x. H of x is 1 over x. At x equals 2, makita natin dito, from the left of x is 2, galing dito, pwede natin i-trace tuloy-tuloy lang to the right of x equals 2. If we trace the graph of the function h of x equals 1 over x, from the left of x is 2 to the right of x is 2, you will not lift your pen. Therefore, the function h is continuous at x is 2. Suppose we are not given the graph of a function, but just the function itself. How do we determine if the function is continuous at a given number? In this case, we have to check 3 conditions. 3 conditions of continuity. A function f of x is said to be continuous at x is c if the following 3 conditions are satisfied. First, the value of the function at c must exist. Second, the limit of the function as x, dapat ito ay x, as x approaches c, exists. And the value of the function at c must be equal to the limit of the function as x approaches c. X ito dapat. Note, if at least one of 3 conditions is not met, f is said to be discontinuous at x equals 3. Okay, so ito yung kailangan natin tandaan na 3 conditions. Dapat yung limit ng function mag-exist, yung value ng function at c mag-exist, dapat equal sila. Example 5. Determine if f of x is x cubed plus x squared minus 2 is continuous or not at x is 1. Solution, we have to check 3 conditions of a function. If x is 1, f of 1 is 0. You can look at the solution here. Limit of f of x as x approaches 1 is limit of f of x cubed plus x squared minus 1 as x approaches 1 equals, this by applying the limit theorem, equals 1. Okay, so we say that f of 1 is 0. Limit of f of x as x approaches 1 is also 0. So, equal sila. F of 1 is equal to limit of f of x as x approaches 1. Ito dapat